All right, it's going to be a short stream today to see if we can finish compressed sensing. Hopefully, it's just the case that we need to implement the proximal operator. Sorry to do. There we go. Okay. All right. I think we do this. Then we do this. Scratch that, we do that. Norm squared, okay. This minus b we'll handle afterwards, so maybe not. Maybe we'll do, I think we do n minus b. We did this before, remember? Prox composition affine. So if we have a minus b, then we take the input minus b and add a plus b afterwards, right? Plus b, great. Going to take the norms. Large norms indexes equal to find norms. I don't like doing that, but I just don't have a lot of time right now. Find norms squared greater than t. Okay, norm squared out is equal to in. Out is equal to, here we go. Out norm squared. Ooh. All I want to do is say, I want to do soft thresholding. No, I want to do a projection onto a ball for each column. For C equal 1 to n coils, and slow, but it should work. If norm squared C is greater than T, else end. Yep. So if norm squared T is greater than T, then I want to put out in R prox. R radius GDC indicator. Okay. It's the model-based reconstruction. Let's stop calling that. Let's stop showing the zero filled. All the adjoints pass. I can vectorize this. Bound. GDC. A half norm of x minus b squared. This isn't defined, right? This is no longer defined. We don't need to do that. We can just check. We don't have to worry about this bound down here. There it is. Oh, apply MF, image not. 0. Great. We've got a feasible problem still. That's always a good sign. Will this run? No. Index exceeds the number of array elements. LP norm squared AP dim. What? No. Where's the optimization? What are we calling like G? We're calling G DC indicator H. GDC indicator. Oh, okay. Okay. Wait a second. What is this? What is the size of diffs? Okay. I don't think I need a BSX fund here, right? I just do subtraction. It's always good to simplify the code we can. If you can't make things work, just simplify the code. At least we'll get something done. 1 by 8. That's what I wanted. I see it's the prox here. Oh, we've got a bug. Got a bug, got a bug, got a bug. Got a bug, got a bug, got a bug. We got a minus b here. Out is equal to out plus b. I guess if we're doing this, we can get away with only doing one reshape, which is good because we have to do that twice. Once for GDC end and once for prox GDC end. We call it twice, I should say. Diffs, okay. Norm squared C. Unrecognized variable C. Oh, right, of course. They're all 0. If max it doesn't matter. Okay. It's running. And it crashed. All right, it looks like we got to a point where we were doing projections. Oh. Okay. Can't get away with doing just one reshape. Reshape shouldn't take too long. So now out is what? B is that. So we're going to send it out as a vector. Okay. Got past the spot where we were crashing before. This will be miraculous if it works. I'll be so happy. Now I want to see the zero field reconstruction. Figure. That looks a lot like zero field reconstruction, doesn't it? Is it not doing anything? Is it still not doing anything? That doesn't make sense, though. I might have the bound wrong. That would probably be my first guess as to if there is a problem, what the problem is. That looks a whole lot like zero field reconstruction. Yeah. Ooh. They're different. CS is not more deep, but they're not different. I think this is just due to the fact that we're doing LSQR after doing the compressed sensing reconstruction. Okay, I'm going to let it run, and while it's running, I'm going to um, look into the bound. Is this right? So this divided by NBC is an estimate of the noise. Of the variance of the noise. So that should be less than the noise variance times NBC. So yet again, it seems like the compressed sensing is not doing anything. Which is very perplexing because we know it's feasible because we check. Zero. The output is 0 for the feasibility. Surely NBC is right. Yeah, it's just NB divided by the number of coils. Okay, so here, norms squared are those values. And the radius, the bound is what? What were the values the first iteration when we had image 0? Now they're 1 times 10 to the 29. Right, because we could get those to within numerical precision. Okay. And then for the next iteration, the norms squared are Still 1 times 10 to the negative 29. 1 times 10 to the negative 29. Ooh, now they're large. And what's the error? The error is 6 times 10 to the negative 7. But aren't these smaller than they were? Yeah, those were all 130 and stuff. Oh, oh, do we need to do that? Or we don't do that because, right, a projection doesn't use the threshold. Okay, we found a bug. Yeah, so with those step sizes, by using the t erroneously, the values were large and we weren't imposing the constraint really at all. Nowhere near as constrained as, by using the proper bound. Oh, that's so not good. That's still just these squares, isn't it? I mean, zero fields. Those are identical. Wait, if the data constraint was like ginormous, let's do this thing again. If the data constraint is enormous, if the bound on the data constraint is enormous, then we should just get like minimizing the wavelet, the L1 norm of the wavelet transform. So that should give us something tiny. So the soft thresholding is not working. The data constraint is working, but the soft thresholding is not. So we need proxGS, prox L2, L1. And that's the issue. It is not reshaped. Now there's a bug. Dimensions of arrays being concatenated are not consistent. What does that mean? Oh, okay. I know what it means. I think that's what it means. So for the multi-coil case, we're going to just give it the handle to that. Nope. Too many input arguments. Right. Now the next question is, so Prox L201 operates on the last dimension of the data. It considers the last dimension the group dimension. And this happens on the image. I need to take a break real quick.
In a can. 2 of those. Blue.
Okay, I got it. I think we need to take the transpose of this. because we want the norm for each coil individually. We could add in a parameter here that is the dimension. This thing thinks it's a 3-dimensional array. Why 3? This should just be multi-dimensional array. You're kidding. We just solved a bunch of stuff and it's still the same? All right. Max norms in is greater than t is equal to 1. Is this ever doing soft thresholding? Doesn't look like it. The threshold here is 142. N is 65536. Wait, so did I not want to do the transpose? Gotta turn off do checks. We're not really doing that anymore. What is this? Size. Oh! Oh! I want to do the transpose after the reshape. Silly me. Silly me. Okay. Now are we going to do thresholding? The threshold's 226 and the norms in are tiny. Let's see if we ever do thresholding, soft thresholding. We never do soft thresholding. Not once has this stopped. The norms in are small and the threshold's like 165 based, I guess, on the values of tau that we're using. Okay, so that's why it's giving us just a least squared answer. So then the next question is, Why is it never doing soft thresholding? Why is the threshold so large? The threshold's 180. The problem's feasible. That means there are an infinite number of solutions because we're like satisfying an underdetermined linear system. With an infinite number of solutions, we'd like to choose the one that has the smallest joint sparsity, and this proximal operator is supposed to do that. Tau is 0.0035, so beta tau, let's just go here, 0.005. Going into the proximal conjugate, going into the proximal conjugate, now going into the proximal operator. Here sigma is the 0.005, so 1 over that is large, 200. Of course, we're going to multiply the input by sigma as well. Okay, so if we go into the proximal operator, this is 200, and these are tiny. Whoa! Oh, right, that's right. What is GCS? L2, L1. I think there's an MBC factor missing. I think we need to divide by the square root of the number of data elements per coil. And so I think we need to divide by the number of data elements per coil there, because we're multiplying by the scalar here. That's what T is for. Okay, Now, do we do soft thresholding? Still no. T is 1.3, and those are like 0.0 something. Let's see, maybe we'll get to it eventually. We're at 25 iterations now. Still no soft thresholding going on. Norms in are 0.1, T is 0.9. Norms in is like 0.3 or 4. T is like 0.8. They are converging to each other, it seems. It appears as though they're coming closer together. T is 1.1. Now norms in is 0.9. And we may eventually... Nope, we're going to get to 100 without ever seeing it. Okay, out of curiosity, what if we did 1,000 iterations? I think this should eventually... So we're going to have to get past iteration 100. Seems like this will eventually start doing some soft thresholding. Oh. The next issue is that for joint sparsity, this should just be the number of coils. Or maybe it shouldn't be anything at all. So this is L2L1. We're taking the wavelet transform. Okay, I did this all wrong. .567, there's a bug. For joint sparsity, we want the joint sparsityness. So hold on. So in here, okay, another problem. 65536 by 8. What does 65536 remind you of? So we want S image and coils. That's really what we should have been doing from the get-go. That was the bug. That was a huge bug. Now this is going to be size 256 by 256 by 8 coils. This is going to take the joint across the coil dimension, which is what we want. We want that to be jointly sparse. And we're already starting norms. So stats of norms in goes up to 0.006. What is T? 180. So why did that stop? Ah, was getting confused between the proximal operator of the data consistency term and the proximal operator of the joint sparsity. Okay. Well, now there's also a problem in GCS, right? Right. Does GCS ever get called? Oh, it does for the line search. Now, I think maybe what I want to do is do we have an image? So that's an equivalent. That's an equivalent problem. I might want to do it there too. We do have an image. That sort of normalizes things, I guess, like dividing by the number of pixels in the image. Then it seems like we should do it here too. Let's just see if this does anything. This is whoa. Right. Max is 0.006, but T is now 0.0028. So now we're doing soft thresholding. I think that I don't know. I have a guess. Not even a hypothesis, just a random, almost random guess. If we ran the number of iterations of PDHD long enough, then we would have started soft thresholding. But the L2, L1 norm increases with number of pixels and number of coils. So what to do? So overwhelmed unicorn. Thanks for joining me. I am trying to make a faster way to scan MRI. So with MRI, the scan time is based on the amount of data that gets collected. The MRI is a Fourier sensing modality, so it just samples data in the Fourier domain. And if you collect enough data, you can reconstruct an image with an inverse discrete Fourier transform. But if you don't collect enough data, then your system is no longer invertible. So what to do? So the thing that I've been working on here I didn't invent, it's been invented for quite a while now, is called compressed sensing, where you assume that the data is sparse in some way. And so you say, for this underdetermined linear system, um, what is the solution if we also assume that it's sparse? And the sparsity that I'm going after right now is called joint sparsity. Yep. If any of that made sense to you, you're probably in this field. And if it didn't, ask questions. I'll be happy to talk to you about it. All right, we're not going to do 1,000 iterations anymore. So, underwhelmed unicorn, the state that I'm at right now is the state I often find myself in. I think I have the optimization algorithm coded up. I'm using primal dual hybrid gradient with line search. Sounds like a pain to work with? No, it's really quite fun. I think I have the optimization algorithm coded up, and it's not working. This is common when you're coding up convex optimization problems. And so what to do? Well, I'm just hunting for bugs now. And already I thought I found bugs and those turned out, and then I fixed them and those fixes were just as bad as the bugs I had found. So that's where I'm at. How's your day going? Okay. Okay. That boggles my mind. So now we know we're doing the soft thresholding. But we're not getting anything different then. Just zero padding? That hurts my feelings. Let's go back to the proximal operator of GCS. Weights. So I can use a weighted L2 and L1 norm. But can I do an L2 weighted L1 norm? Underwhelmed Unicorn says, never touched it, just hobby, programmed a few games, some that ended up on App Store. Never earned enough money to cover the investment. But you made games, man. Or woman. I have no idea. You made games. Finishing something is really hard. It's the hardest part of engineering. Everyone starts a project with so much hope and so much glee, and the budget's ample and everyone's getting along, and then the project progresses. You're a dude, okay. The project progresses, and then budget constraints show up and things don't go as expected, and you end up with an implementation of a convex optimization algorithm that isn't working, even though you think it should be working, and you start to get discouraged. It's real hard to push through that discouragement. And you did it. You finished some games. Do you have a website for these games? Can we check it out? I'm not going to have too much more time to stream this morning. if you show me your games, if you have a website or something, that might be the end of this stream, which would be a really good way to end it. Okay. This was a hack. Let's get rid of it. It's not really a hack. Like, so this does a weighted L2, L1 norm. It weights the L1s, right? Yeah. It weights the sum of the L1. Does LP norms have a weights property? No. No longer up, hasn't been up since 2017. Okay. All right, folks. I'm afraid my other duties are calling. We made some progress today. I guess I'll see you guys next time. Thanks for stopping by, Underwhelmed Unicorn.